Hello everyone, my name is Manya D'Souza and today I want to share with you my personal take on blockchain technology. When I first heard about blockchain a few years ago, I'll admit it, I was a bit skeptical. It sounded like a buzzword only tied to cryptocurrencies and I wasn't sure if it was all a hype. But as I dug deeper, my skepticism turned into fascination. To me, blockchain is more than just Bitcoin or crypto trading. It's a fundamentally new way of storing data and securing trust in the digital world. In my journey from skeptic to believer, I realized that blockchain has the potential to revolutionize how we handle information and transactions. Imagine a world where you don't have to blindly trust a big bank, a hospital, or a government office to keep your data safe. Or, to be honest, because the technology's design ensures transparency and security. That's what excites me about blockchain. It shifts the need for trust away from fallible humans or institutions and puts it into math, code, and a network of users. As a tech enthusiast, I find that really powerful. Now, I'm not saying blockchain is a magic fix for every problem. It's a young technology, and it comes with challenges like scalability and regulatory questions. But in my view, the core ideas of blockchain, decentralization, transparency, security, it's like we've discovered a new blueprint for the internet age, where trust is baked into the system itself. In this video, I'm going to walk you through some of the key concepts behind blockchain in a technically rich yet hopefully accessible way. I'll explain terms like decentralization, distributed ledgers, consensus mechanisms. You've probably heard of proof of work and proof of stake, smart contracts, immutability, cryptographic security. Don't worry, I'll break this down and so that they make sense even if you're not a blockchain expert. After that, we'll dive into real-world examples of how blockchain is being used across various industries, from finance and healthcare to supply chains and even entertainment. I'll keep the tone casual and straightforward, so grab a coffee and let's unravel the world of blockchain together. Alright, so what is blockchain? At its heart, a blockchain is a type of database, but not your typical database on one computer or a server. It's often described as a distributed ledger, that is, decentralized across many participants. Let's break down what that means. Decentralization. This means no single entity is in charge. Instead of one central authority, like a bank or a company server, controlling the database, a blockchain runs on a network of many computers, often called nodes, all around the world. Each node has a copy of the ledger because it's decentralized. The system doesn't have a single point or of failure or control. For example, if one node goes offline or a few bad actors try to manipulate data, the network as a whole is unaffected and will reject this fraudulent change. Think of it like a group project with no single leader. The group only accepts work that everyone agrees on. This decentralization makes blockchain networks more resilient and in many cases more democratic in how decisions are made. Distributed ledger. A ledger is basically a record of transactions like a database or a spreadsheet. Distributed means the ledger is shared and synchronized across multiple computers or sites rather than kept in one central place. Every participant node in the network maintains a copy of the entire ledger. When a new transaction or a batch of transactions called a block is added, every copy of the ledger is updated. This distributed nature ensures that everyone sees the data. It's transparent. Anyone with access to the network can verify a transaction for themselves by checking their own copy of the ledger. Imagine a Google Doc that everyone in a group can see and edit in real time. Except in this case, once a line is written, it cannot be changed. We'll get to the immutability part soon. Consensus mechanisms. With so many copies of the ledger, the big question is, how do nodes agree on what the true ledger is? This is where the consensus mechanism comes in. A consensus mechanism is a protocol that network participants follow to reach agreements on the next valid block of transactions. Two major consensus mechanisms you've likely heard of are proof of work and proof of stake. Proof of work. This is the original consensus mechanism, famously used by Bitcoin. In proof of work, nodes called miners compete to solve a complex mathematical puzzle. Solving a puzzle requires a lot of computing power, essentially a lot of work, hence the name. The first miner to solve the puzzle gets to propose the next block and is rewarded, usually in cryptocurrency. The proof of their work is the solution they found, which is hard to find, but easy for the others to verify. Proof of work makes attacking the network extremely costly because you need to control more computing power than the rest of the miners combined to fake a block, which is practically infeasible for a large network. The downside? All the computations use significant energy, and this limits how many transactions the network can process at a time. Proof of stake. This is newer, more energy efficient consensus method, now used by networks like Ethereum since it transitioned from proof of work, and others like Cardano and Polkadot. In POS, there are no miners racing to burn energy. Instead, validators are chosen to create new blocks based on the amount of cryptocurrency they hold and stake as collateral. It's kind of like a lottery. The more you stake and the longer you hold it, the higher chances are of being chosen to add the next block. When a validator is selected to propose a block, other validators will check or attest that everything in the block is valid. If the block checks out, it gets added to the chain, and the validator, and often those who helped attest, earn a reward, like interest on their stake coins. If a validator tries anything fraudulent, they can lose a chunk of their stake coins, a punishment called slashing. This economic incentive keeps validators honest. The result is that POS can ensure security within the network with far less energy use. It also can make more scalable decisions in terms of transactions per second, though the security model is different. It relies on value of stake rather than raw computing power. In short, POW relies on computational work while POS relies on financial stake. Both are ways to get distributed participants to agree on a single version of truth. Now, smart contract. So far, we've talked about keeping a ledger of transactions like who sent money to whom, but blockchains can do more than just record payments. Enter smart contracts, one of the most powerful innovations in this space. A smart contract is a piece of code that lives on the blockchain and automatically executes when certain conditions are met. For example, if I put a certain amount of cryptocurrency into a smart contract, it could be programmed to automatically send back an item or distribute that money to someone else based on predefined rules. Once deployed, no one can alter the code of the smart contract. It's immutable, just like the blockchain it resides on. So, everyone can trust that it will run as programmed. Smart contracts let developers create all kinds of decentralization apps, like dApps. From decentralized finance protocols to games and marketplaces. They remove the need for an intermediary or a middleman in many scenarios. For instance, a smart contract can hold funds in escrow and release them only when both a buyer and seller have done their part in a deal, all automatically. This concept was popularized by the Ethereum blockchain, which was built explicitly to support smart contracts. Now, many blockchains can run smart contracts, enabling things like decentralized exchanges, lending platforms, NFT marketplaces, and more, all governed by code rather than companies. Immutability. Earlier I had hinted that once something is written to a blockchain, it can't be easily changed. This property is called immutability. In a blockchain, when a block of transaction is confirmed and added to the chain, it's essentially permanent. You cannot go back and edit or delete those transactions. Why? Because each block is cryptographically linked to the block before it, hence the chain. If you try to alter the data in an old block, that block's unique cryptographic hash, its fingerprint, would change, breaking the link with the next block. All subsequent blocks would become invalid in everyone else's ledger copy. So the network would immediately see the tampering happen and reject it. In simple terms, blockchain is like writing with ink instead of pencil. It's write once and read only thereafter. This immutability is powerful for record keeping. It provides a tamper evident log of all transactions, whether it's financial transactions, supply chain records, or votes in an election. Once recorded on the blockchain, you have a reliable history that can't be doctored behind the scenes. It's worth noting that if an error or fraud does get recorded, you can't delete it. You'd have to add a new transaction to counteract it.